Hello and welcome back. This is the second video for this module number 7, and this time I'm going to talk about open source R, and I'm going to provide you more insight into R and why are we looking for that. And so we are going to look at functions, we are going to look at vector, we are going to look at character and string and factors and how we import data to R. However, we need to start talking about computer organization and structure, which means that every computer has 6 basic structure: input, output, memory, algorithm or logic unit, central process, and secondary unit, which is usually the floppy drive, the hard drive, etc. One of the things that we need to be very concerned about is that the processing task of the operating system. And nowadays, all the computers that we are running has multi-programming, can do 2 jobs at the same time. In my days, it did not happen, but we are lucky to see that alive, and we are trying to capture that very well. So, personal computer. It's become the standard in nowadays how we work, but it was introduced in 1977, and in 1981 IBM introduces off-the-shelf components, which becomes a desktop and become a standard. We are talking about levels or programming levels that R has, and what type, how we classify that. Usually, and I'm sure that you learn it in other classes, we are talking about 2 types of programming language: machine language and assembling language. And each one of them has its own syntax and own structure. High level usually get closer to everyday English, and we are be able to provide the structure in order for it to execute. So we have something that allowed us to execute that, and in return we are allowed to do some more manipulation or operate the compiler in order for us to execute that. So high level, we have Fortran, COBOL, and Pascal. All of them are old languages, but they are the structure of any programming language. One of the things that we need to remember, and I hope that some of you already took the Dr. Sullivan class about the idea of objects. It is a meaningful software units, which is, it is considered to be a data object, time object, example, check, paycheck object, invoice object, etc., etc. But they are allowed us to organize or maintain a procedure in the programming environment, and that is part of the reason why we have a very strong essence in that in R. So let's start with storing information inside the R as an object. So the first example allowed us to have a container which we will call A, and it will contain one object which is 1. And so in that sense, we are allowed to manipulate this one with adding +2 and -2 or etc. And this is the object that we are creating in R. We have to have symbols, we have to have some structure, a syntax in order for the object to operate, but R follows the same context. So good names versus bad names. One of the things that I highly recommend, do not use the $sign on R. R does not, or RStudio do not like it, so do not use it. And again, if you want to see what you have already has in the R using the ls function, he will show you all the names that you have right now in your system, and so you will not override them and be able to do that. So in R, we are talking about a lot of functions. What is a function? So it is a programming style that emphasizes on the expression rather than the execution of the commands. It is a name section of a program that performs specific tasks. So in this case, in the R, the functions allowed us to do simple or advanced statistic analysis. Example that you already entail is that the standard deviation is a function in R. Instead of writing a standard to execute the entire formula for R in the programming language, you can say ST or SD and run the function on that data set or that container. So the function, it is the mean, the idea of it. So example, the mean. If you want to calculate the mean of a container that you have 1, 2, or 3, you will say function mean, and he will give you it. You will open the container that contains the data set and you will run it. And so those are the functions, and I gave you all the short list or all the reference to functions that we are going to encounter in the class with regard to statistics, advanced statistics, and analytics, and I want you to become very familiar with them. Why? Because you will need them in order for you to sort the data, to operate or to calculate, and to become familiar with that is a good way for you to do that. So the data that you pass into the function, it's called function arguments. So in this case, the mean, I call it a function, and the argument is 1 to 6, and by doing that I can calculate the mean between 1, 2, 3, 4, 5, and 6, and it will come up with the result, and those results are the basic arguments. You can also write your own function. It's not that R only give you establishing a function. You can write your own function, which is the biggest assets of the R. Unlike Excel, unlike SPSS, unlike any other software application in statistics, the R allowed you to learn and to write your own functions, which is quite cool. And again, the issue of this idea. Let me illustrate this idea. So we have a C, which is a container that hold 1 to 6. We will say a function called C, and we will say size 2, and with a replacement to the sample will be true. So with more details about the replacement or without a replacement, this is what we are going to do and how to differentiate. And I want you to go over the slide to make sure that you understand the idea with regard to sample with replacement and without a replacement. And a function are the first class object, which means that they can treat it much like any other objects. And you can also have 3 parts to the function: a name, a body, and a set of arguments. To make your own functions, you need to replicate those parts and store them into your R environment. So the syntax of R, the function in R, has to be name argument, which is potentially default values. You need to have formal argument, such as argument including the function definition. You need to have formal function returns a list of all function arguments of the function, and not every function called in R makes a formal argument. And so what is a normal distribution? A normal distribution, as we learn in my chapter in my book 7 and 8, is the idea of a bridge between two subjects. And I will talk about more later in the semester. I will talk more about normal distribution. So the normal distribution function in R, as a functions, we have R normal, D norm, P norm, and Q norm. Each one of them has a different function with regard to what they can do and what can they provide us. The syntax inside those functions, example, you can calculate the mean, you can calculate the standard deviation, you can calculate all those things that usually comes along with those normal distribution. So, example of normal distribution. We have two premises in the normal distribution, the mean and the standard deviation. So again, if you are looking at the family of norms that to be standardized to normal with a mean of 0 and variance of 1, it is achieved by standardizing the numbers. This is the formula that we learn. Z is equal to x minus the mu divided by s. And by doing that, we can do our norm 1 and 116, which is the length of the textbook. And we will do the normal distribution, and it will give us the normal distribution of that container of that data set that entail. So again, how to apply that, how to apply, example, the histogram. The histogram has the probability of true. The color is gray, and we can have main title to the histogram, and the sigma is equal to 1 in order for us to apply that, and this is the syntax to do that. The vector is a sequence of data elements of the same type of data. So the members of a vector are officially components, and nevertheless they are called members of members. And so here I took, this is from my notes from the website, so this is my mistake, but here the vector contains 3 numerical values, 2, 3, and 5, and in this case we can convert it into logical values, true, false, or false, true, and give it additional elements. So this is the role of the vector. Using logical vector as an index, and again, this is the idea behind that and how to apply that into that structure. Using the character vector as an index, I also talked about that in the past, but I want to make sure that you understand that, because one of the things that we will learn in analytics is using character vector as an index in order for us to simplify the formula that we are going to generate. You can modify the vector, and modifying is as illustrating in this slide. And again, this is something that you have to be careful when you are using it or deleting the vector. Again, you can use that, but make sure that you understand. The idea, one of the criticism about R is inability to display dimensional data as we are accustomed to see in Excel or spreadsheet. And so the matrix is much similar to the idea, of vector, but we're allowed to add more dimension to it. In this case, the A has a 2-dimensional and 2 functions that allowed us to do that. In R, we will call it the R matrix, and we will add row, and we will have columns, and we will say fill matrix by row, and that's what we will get out of it in order for us to show that in that context when you are applying that. And again, this is something that you are in the control, you are the one who decide that. A list in R is also very important. A list is a generic vector containing other objects. For example, the following X value is a list containing copies of 3 vectors, N, S, and B, and a numerical value of 3. So in this case, all those values has vector or container. Vector or container almost is the same meaning for me, and in this case I can add them together in order for you to have a list of all those container, the N, the S, and the B. So again, I can display that, I can slice it and integrate that. Integer is also part of what we are learning, and we use the integer or the whole numbers as positive and negative. So you can declare that also in the R as integer -3 or +3, whatever is your integer, and this is how you do that. A string is a collection of character. So a string is a data type integer that present in the form of text rather than numbers. So it comprises a set of characters that contain space and number, for example, hello, and I can add to it hello plus 3, plus 4, etc. Characters is also a single element, such as a letter of the alphabet, or punctuation, or numbers. In order to convert object into characters, we need to do the following. X as a character, and it will declare it as a character. Or my first name, and it will paste as my first name, last name as a character. Factor is, again, the idea of ability of manipulation. In R, factor takes a limited number of different values, such as variables that are often referred to as categorical variables, and in the text we define categorical variables which represent type of data that may be divided into groups. And example, the color of the hair. I don't have hair, so I am not in the list, but in this case we have blonde, black, white, gray, blonde, white, and black, and that's where the factor come into play. We are declaring it as a factor, and by doing that, it will lay out from us what is that container or those color of hair consist of. Logical is also part of the true false, and that where we can do that and how to apply that. And again, we can assign values or logical values onto the R. One of the things that we will learn and import is really easy in R is to import data. In this example, I illustrate how to import data in the code itself. From Excel, I highly recommend that if you are using Excel, use it as a read table and import the data. From the web, you can do read table and give you the URL. And again, with the R, sorry, there's an open so fast. Sorry. Sorry. I may open it already. Sorry, my mistake. Nope, it doesn't open. Okay, so in RStudio, which is quite easy, you have two options. The first object is that from a new script, you're going to say to the R and choose files, new folder or new files, and you're going to select where your files located in my desktop, and I will select the type of data that is already there, and I will import that, and it will be part of my import and part of my structure. You can use other application, but I highly recommend try to do that as simple as possible, as straightforward as possible, and I will try to, in the future, try to give you more techniques to do that. Another element is the matrix. In mathematics, is a collection of numbers arranged into a fixed number of rows and columns. In R, it is a collection of data elements arranged in 2 dimensions. So we have columns and row, and so the M is multiplied by N, which is the idea of it, and we do idea of how to apply that into calculation. And so the idea of matrix manipulation is part of what statisticians and mathematicians often do, and that's what it does. So I gave you an example again from the matrix and how to apply that, and to create a matrix with the 2 rows and how to apply that. general matrix operation is also important. I want you to go over that and try to understand what I've done. This is one of the following example is the structure of the R. This is the one of the biggest ability to add more functionality to the R commands. It is the percent multiplied by percent allowed us to add more example or more manipulation to it. And again, I will talk more about this idea later on when we will try to capture new formulas or generate new formulas. This is part of the things that we will learn how to use and how to look at that. So again, a different look of a matrix and how to apply to it, a different look. And matrix indexing is also part of the syntax that I want you to become familiar with. And again, I gave you an example, I gave you idea. I did not talk about negative values that can be applied and matrix filtering, that you can filter the data based on a filtering function, and in this case it will provide you. A textbook provides us example of the matrix and how filter it by provide us this filtering, and by doing that he allowed us to minimize the structure of the data. But the biggest issue that I want you to start become familiar with, and I want you to have this terminology quite often. Data frame. It is the way for us to store large set of data, and a data frame is a two-dimensional array like structure in a column containing a measurement on one variable, and each row contain one case. But in data frame, we are allowed to do in R, we are allowed to do things that usually it's hard to us to do. So the idea of in R, it represents as a typical type of list where each element of the list has the same length. Unlike matrix, the data frame allowed us to store different object data type into each columns. The data frame also have a special attributes called row.names, which annotate the data. And the data frame also used to create read table or read CV. So in this case, it's already stored in your machine, the data frame, and by doing that, you can convert it into the data frame and call it anytime. So how do you create a data frame? df is the name of the data frame. In this case, I gave df, and I said data.frame, and I said face, and I equal ace26 and food and values, and by doing that the data frame hold those values together and allowed us to manipulate that in that context. The syntax of data frame is as follow. It has data frame, it has a vector, it has the values that we can create. We can create a list inside the data frame if we want to. We can create a vector from the matrix inside the data frame. So it is a powerful tool, a very powerful tool into the R. How do I change the data frame row and columns names? The data frame has names attributes, which you can see the names of the variables, so you can include into your data frame. In other words, you can set the header of your data frame. As a result, you will see the names of variables appear on the data frame. So the type of data: vector, matrix, array, data frame, list, and vector. We cover this in this module, and as part of module number 7, and I want you to become familiar with it because this is the syntax that we're going to work in R. So in R, object is the vector has one dimension, the matrix has 2 dimensions, the array has 2 or more dimension, the data frame has 2 dimensions, like table that allowed different data types for different columns, and we have a list which is a list of all the dimensions. So what is a package? A package is extensions of the what you have done, what is the function you created in the package. Example, in ggplot2, he created a function that allowed us to convert data into visualization. Or histogram, it contains the histogram function. So all those things are part of a package. So how to install package? It's quite easy. In the RStudio, the installment of a package, if you are interested in a package, you go into the package. Usually there is a list of packages that already embedded into your R. And if you look at my previous packages, Lotka's, let's see, search for Lotka. He will not find. If you don't have it in your hard drive, he will say, okay, you can install Lotka, Lotka's lore, and this is my package, and you can install it. We will not learn about my package, but this is not the issue. The issue is how to use it. Again, the RStudio and console has different syntax to it, and I hope you will start using packages in your own work. So we talked about today about a lot of things: functions, vector, numeric, integers, string, character, factors, logical, and how to import data. What I want you to remember is all those terminologies, but in addition to data frame. So that's it for now. I hope you enjoy it, and if you have any questions, please let me know. Until next time, have fun.